Once again, get a new page, write down your homework problem number or the learning objective number. Get out your quick reference sheets with functional group names and naming rules. You have some problems converting Lewis structures to skeletal structures. So I'm starting from the name just to get some extra practice there. Pentane. Pent tells us we've got 5 carbons. And ane tells us they're all connected with single bonds. They're alkanes. Put the hydrogens on to complete the number of bonds. So this is your starting point for this problem. From here, you need to convert to a skeletal structure. I love skeletal structures. They're so quick and easy to draw, and they show off functional groups really well, but I just put my pen down for the first carbon and draw a line to the second carbon. Second to third, third to fourth, fourth to fifth, and we're done. There's pentane. So second one, methoxyhexane. Start with the root. We've got 6 carbons. Methoxy attached to it tells me I've got an ether. So I go OC. Meth tells me there's 1 carbon in the ether. Now I finish it off with all the needed hydrogens. Every hydrogen takes 4 lines to draw. It's really nice when you can just leave them out. Saves you 4 lines for every hydrogen. So I start with my first carbon, 1, go to 2, 3, 4, 5, 6. Then there's an oxygen and 1 more carbon, and the skeletal structure's done. So much quicker and easier. As long as you can learn that's a carbon with 2 hydrogens attached, you're in good shape. All right. Now here's a molecule I made up just to practice haloalkanes. Just a reminder, halo refers to the halogens, fluorine, chlorine, bromine, and iodine, and those all single bond to carbon. So let's start with our root. Nonane. It's going to have 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. These numbers tell us which carbon to start with, so I'm going to start my numbering on the left, but you can start it at either end. Write these small numbers. You might not be able to see them well, but I'm writing the numbers 1 through 9. Iodo means I put an iodine at 1 and 7. So there's an iodo, and there's another. Doesn't matter which side I draw them on. 3 bromo. At 3 I attach a bromine. 6 fluoro. At 6 I attach a fluorine. Then I draw in the rest of the hydrogen. You would have something like this as your starting point for the problem to go from a Lewis structure to a skeletal structure. So again, I start with my first carbon, put my pen down, draw to the second, third, fourth, fifth, sixth, seventh, eighth, ninth. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've got an iodine on the first one. These bonds can rotate, so if I draw it in a different place, doesn't matter. Second, third, a bromine. Fourth, fifth, sixth, seventh, a fluorine. Eighth, that's my mistake. The seventh is an iodine. The sixth is the fluorine. And that shouldn't be there. It's on 8 and 9. Okay, so that's my finished molecule. If we were doing this in more detail, this bromine here and this fluorine and this iodine would all have stereochemistry. They might come out towards you with a hydrogen going back away, or maybe they'd go away and the hydrogen would come out towards you, and they would have these stereochemistry for those who are learning about that.